Hello students, good morning. Our topic today is waves. From our plan of action, we need to know the definition of a wave, how waves are being classified, and some definitions involved in waves. So the first thing is our definition. Wave is defined as any physical disturbance that causes energy to be transferred from one point to another. Second step is classification of waves. Waves are being classified in two types. We have mechanical waves and non-mechanical waves. Mechanical waves are waves that requires material medium for their propagation, meaning that it requires material medium for movement. And an example of mechanical waves we have transverse waves and longitudinal waves. Non-mechanical waves we call them electromagnetic in nature because they don't require a material medium for their transmission. Now, looking at mechanical waves can be grouped into transverse and longitudinal. What is a transverse wave? A transverse wave is a wave in which the particles of the transmitting medium are vibrating perpendicular to the direction of propagation, meaning that they are vibrating at right angle to the direction of propagation. This is an example of a wave profile of a transverse wave. An example of a transverse wave is water wave. Longitudinal wave, that is the second type of mechanical wave. It is a wave in which the particles of the transmitting medium are vibrating along the direction of propagation. And an example of a longitudinal wave is sound wave. Now, this is the wave profile of a longitudinal wave, and this is the wave profile of a sound wave. Now, if we look at the differences between longitudinal and sound wave, we shall see that in the longitudinal wave causes compression and rarefaction. Compression is a situation where waves are being squeezed together than normal, while rarefaction is a situation where waves are being extended than normal. Okay. The first difference between longitudinal wave and transverse wave is that for longitudinal wave, the particles of a transmitting medium are vibrating along the direction of propagation, while for transverse wave, they are vibrating at right angle to the direction of propagation. The second difference is that you see that compression, longitudinal wave causes compression and rarefaction, while transverse wave will cause crease and troughs. And then the third difference will be the example for longitudinal wave, an example is sound wave, and for transverse wave, an example will be water wave. Now, there are certain terms we need to know in waves. For instance, we have trough, we have crease, we have wavelength, we have frequency, and we have amplitude and time. Amplitude. Okay? I will start with wavelength. Wavelength is equally called lambda. Lambda means, it is a Greek word that means distance, and lambda is being measured in meters. So lambda is the distance between two successful creases. This is a crease and this is a crease. The distance between these two creases is what we call the wavelength. And a crease is the highest point reached by a wave. So that's the definition of a crease. The highest point reached by a wave. While a trough is the lowest point reached by a wave. The second definition is frequency. Frequency is the amount of oscillation or the amount of wave cycle made in 1 second. And remember the SI unit for frequency is Hertz. The next one is time. We say time is the time taken to make one complete oscillation or one complete cycle. The last one is amplitude. When we go to amplitude, look at the diagram here, this is the amplitude. This is at the point of rest. That is why I'm marking 0. So amplitude, it is the maximum displacement of an object from its rest position. Meaning that from this 0 to up at this point is the amplitude. Or from this 0 to down at the trough is the amplitude. Okay, students, we are in the second part of waves, where we need to study the properties of waves. The first property of wave is wave equation. The wave equation states that V is equal to F lambda, where V is equal to the velocity of light, F is equal to the frequency of the wave, and lambda equal to distance in meters. Therefore, from this equation, we can look for a frequency if at all the velocity and the lambda is given. We can look for lambda if at all the frequency and the velocity is given. So V is equal to F lambda is equation 1. Now we are looking for F. If we are looking for F, which is the frequency, F will be equal to what? Looking for F, we know that V is equal to F lambda. Therefore, we need to divide both sides by lambda. We divide here by lambda, we divide here by lambda. So F is equal to V all over lambda. This is equation 2. This is equation 1. Okay? We are looking for lambda. Looking for lambda. Lambda, we know that V is equal to F lambda. So we are looking for lambda, we divide both sides by F. Divide both sides by F. This will cancel this. Therefore, lambda will be equal to V all over F. This is equation 3. So with these 3 equations, you can solve simple calculations involving in waves. Good. The second property of wave is diffraction. We said diffraction. Diffraction is the spreading of waves as they pass through openings. Diffraction is the spreading of waves as they pass through openings. That is the reason why you can hear people talking without actually seeing them. Now, looking at the diagram of diffraction here, this is our diagram A and our diagram B. Diagram A, we discover that the wave front forms a circular part of it because this gap between is a narrow gap. Meanwhile, in diagram B, the waveform is a bit sharp at the ends because the gap form is a wide gap. So if they ask you application of diffraction in physics, we know that diffraction is possible for you to hear people without seeing them. The third property of wave is refraction. When we talk of refraction, we simply means the change in velocity of a wave. A change in velocity of a wave as it passes from one medium to another. For instance, this is a medium for me. So if I'm passing my wave through this medium, automatically the velocity will change because there is a medium present. But in a situation where there is no medium, if I pass my wave, it will just go straight. So from our definition, refraction is the change in velocity of a wave as it passes from one optical medium to another. An optical medium is the ease with which a medium transmits light. It is the ease with which a medium transmits light. The fourth property of wave is reflection. 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 Okay? Reflection is the bouncing back of waves as it hits a barrier. The bouncing back of waves as it hits a barrier. This is the barrier here. So as this wave goes and hits this barrier, it bounces back. This is a phenomenon called reflection of waves. And then a fifth property of wave is interference. Or talk of interference, we mean a situation where two waves superimpose each other. Two waves they superimpose. This is what we call interference. When two waves superimpose each other. This is wave A and this is wave B.